Good morning, everyone. This will be a presentation on the Arc NLET extension to be found on the Florida State University website. I have links to, and I will provide it at the end if anybody wants them. The Arc NLET tool, the NLET stands for Nitrite Load Estimation Toolkit, and that is what it does. I'm Joe Cavallaro, by the way. I work for Flagler Co GIS. And yeah, we're going to go over the NLET tool. So let me start this. All right. So there we go. Quick description. I'm not going to say that this extension is owned by Florida State University. I'm pretty sure it's not. It is just provided on their website, is where I found it, and where all the documentation on how to use it is stored. So it's provided on their website, and we saw it used for the first time in a county around Flagler to measure the outputs of the septic tanks in a local community and show their how they were leaking basically into the local aquifers and water bodies. So we were excited to implement it and see, since we have a lot of intercoastal water bodies and people that live on the water, we're excited to see how we could represent and show people the benefits of maybe providing city sewage instead of people having septic tanks. So the tool is broken up into 4 modules or steps, each one giving you a necessary output to run the next step to eventually give you your information points for each septic system, as well as the plume graphic. Yeah, it goes groundwater flow, the particle tracking, transport, and load estimation. And to use this tool, you're going to need a few basic layers. You need a digital elevation model, your water bodies polygon, and a soil survey, a polygon shapefile that has the soil porosity as well as the hydraulic connectivity. Those are necessary to run parts of this tool. So in the SOP we have for using this tool now, I generally set up the workspace that someone works in, or I have them set up their workspace fresh, because the different layers, the different raster layers, do not like to work together in this tool. It was somewhat difficult getting it to run easily, piecing together so many different layers and files, and eventually what we figured out was that they were brought in with different cell types or cell sizes or spatial references, or the elevation model was in meters and not feet. So building it all in one workspace, exporting into that workspace using the spatial reference from one place made testing different areas much easier. So with all these layers that you have, your elevation model, your water bodies, the soil polygon that you will turn into 2 raster layers. It helps with the flow of running the tool if they are all exported and are all using the same spatial reference, the same cell size, same cell type, things like that. All right. Okay. Again, this is about just getting the layers that you'll need to run the tool ready. This is building rasters from your soil survey polygon. You, as shown in the image below, we have the attributes for the hydraulic conductivity and the porosity in there, and we just built the polygons using the polygon to raster tool from this layer, and we made both a hydraulic conductivity and a porosity raster layer, and those are necessary to run the groundwater flow part of this tool, which is the first step to get your plumes and your information points. I had to go through a few different soil surveys to get Flagler County a complete list of all our soils that we had listed in our survey, and then attached to that the 2 fields, the hydraulic conductivity and the porosity. We didn't have those in our original, the ones that I had found. So the hydraulic conductivity is also sometimes referred to as the K value of soils. So if you're using a soil survey from your own organization and they have a K value, that's the hydraulic conductivity. Porosity is usually just spelled out. But those were difficult metrics to find for the most part. All right. The groundwater flow tool. This is the first one that you'll use when running the Arc NLET tool. It uses the digital elevation model, the water bodies, and those 2 rasters that you had to make from your soil survey. And this will output 2 files that you need to run the particle tracking step of the tool, the velocity magnitude and the velocity direction. Those are also outputted as 2 raster files. One of them, the velocity direction, is shown in the graphic below. And they don't appear like much just looking at them, but the tool needs them for elevation and flow direction in the next part. The particle tracking step of this tool will produce these lines, which is the direction that water will be flowing from the septic tanks to usually depressional areas, or the closest body of water is what they normally flow to. And the tool itself seems to make the paths pretty accurately based on just looking at the elevation model and looking at the water bodies. And when you have the soil survey turned on, you can see how it will flow easier through certain types of soils, depending on those metrics, the hydraulic conductivity and the porosity from earlier. And the paths will be stored on a temp folder as you're doing this, and they'll be pulled in as you go to the next steps, and they'll also be put into your map into temp files. And you can set it to keep those temp files or delete them. I mostly have the temp files stay after the tool runs, because some of them are still useful afterwards. The transport tool. This is the tool that will, well, one is where you will customize the output that you want based on more for environmental scientists or people who deal with nitrogen plumes and outputs in that sense would know more what to do in this section as far as maybe the size or the total daily maximum value of the tank of what it can put out. But this is where you can customize the output, and this will give you your plumes, the graphic that people really like to see when you run this tool. Not so much the information points, but people really like to see the graphic. Okay. And the load estimation, which is actually the final product of this tool, is this point layer that the plumes are attached to and generally represent, but also a lot more information that's used to measure the mass output for the septic tank itself. This is again something that an environmental scientist is going to know much more about than your standard GIS user. But the tool uses, as it comes, average information for septic tanks and will output based on the amount of points you have and your soils and your water bodies relatively useful information as far as actually tracking the nitrate and nitrite plumes that come from them. So a lot of useful information. A lot of it is more meant for other entities, but that is a lot of what we do, is running the tool itself and the analysis, and letting the subject matter experts decide what to do with their information. But if done correctly, you have the points that you could run through the load estimator that will give you more accurate and defined information based on that point itself. And you also have the plume graphic that you can overlay onto a base map and show the septic tank discharge flowing into the local bodies of water and how far they're going and the magnitude of which they are flowing. And it gives a really good picture for well, good argument as to why a city sewer system might be more beneficial for people living in barrier islands or along large bodies of water instead of these individual septic tanks. And yeah, that went kind of quick, but I'm open to any questions. If anybody has any?
Got one question so far. Are the developers of this tool planning on transferring this to Arc Pro?
So I haven't even seen an updated download for the new Arc map. And I would be surprised if an Arc Pro one came out. I'm hoping it does. I know that it still works on the new version of ArcMap that just came out after we just updated. So while there isn't a new one out for the updated ArcMap, it still works from the old one. I hope they go to Pro, but I'm not aware of any steps of them doing that.
All right. Any other questions?
Is there a chat? I don't see it.
Does this tool only work in a superficial type aquifer, or can you run it where you're close to a very porous limestone?
I'm sure. Well, you don't actually need the water body's layer itself to function. You can actually turn that off, and there's an option. Let's see if I can go back. So the short answer is yes. You can use it in just on soil, not near large water bodies. There's an option called fill sinks in the groundwater flow, which is where you do this first. There's an option to fill sinks, and you won't need a water bodies layer. So yes, you can do it on just an area that's only soil where you don't have large water bodies, and it won't require you to have that layer.
All right. So is this tool only geared for septic systems? Or could you apply it? Is there a way to apply it to, say, a large tract of land adjacent to Lake Okeechobee, like sugar crops?
Like a farm, like farmland.
Yeah.
That would be, once again, that's a question for how to adjust the parameters. It gives you a lot of ability to adjust the size and the output of here in the transport module of the point itself. So what all these things mean would require a degree that I don't have, and the map that comes along with it the same. But I would assume in this area where you customize the output of the actual your source locations, it doesn't say septic tanks. It's used for septic tanks from the examples that I've seen. I don't see why you couldn't do it for a large field if you understood the metrics of how it worked.